Alrighty. Hey guys, welcome back to another video on my senior project, a personal pick and place machine. Now it has been a couple of weeks since my last video and it certainly shows. We've made a lot of progress here in the lab and happy to say that we're about 80% done, just about. Now today I'm gonna run through some of the accomplishments that me and my team have made along the way. Some of my personal achievements, and then I'm going to run through a small dry test, and then we'll do a live component test. Now before I do that, I would love to show you guys just how small these components are that we're dealing with and just how accurate this machine really is. Now, let's see if I can get on this. Sorry about that. There we go. Yeah, this thing is small. Camera won't even focus on it. That's how small it is. So you really have to take into account how accurate this machine must be to make these pickups and precise placements. Now, one more resistor. I'm only doing 4 today. See from our strip here that max we can do is 5. But in the future, we do plan on adding some stuff, and I'll go over that later to really boost our efficiency and get this whole board made eventually. But yeah, all right, so let's start with some of the things that we've all accomplished together. So we made our headpiece here. Now our headpiece it's composed of our Z-axis and our A-axis. Our A-axis is attached to our head here, as you can see. We'll rotate right there. And then we have our Z-axis here, which is just glued onto the stepper motor, but hey, it works. It was the design choice that the mechanical team wanted to go with, and results are results, and I can't argue with that. I've stress tested this thing heavily and it hasn't failed once. It doesn't buckle, doesn't shake, so you know, results are results. And then implemented this cable management system, this cable drag chain here. Now compared to other pick and place machines, our frame design is a little bit different. We actually ended up recycling an Ender V3 or an Ender 3V2 3D printer. Now this is actually the Z-axis of the printer, and we laid it flat, and this is how we're this is our X and Y axis now. So that makes this thing really quite different. So the way we had to do the cable chain required some custom fabrication. I designed these parts in FreeCAD. They're here to hold my chain in place and allow for the chain to move back and forth through it, keeping everything tidy, tucked away, and sleek. Now over here I built this board. I call it my ESU, the electrical storage unit. Now this houses just about all of our electrical components besides our Jetson Nano. Our Jetson Nano is currently hooked up over here, and I'll talk about that later. But right now, the CPU that I'm using is actually just through my laptop. So that's the only thing that we're missing, but other than that, we have our DC buck, we have our 2 relays, vacuum pump, air solenoid, our Tiny G motion controller. Now, I think the only thing that you guys haven't seen yet from my previous videos is likely the solenoid. Very cheap, but gets the job done. Obviously, the point of this project is to give you your bang for your buck. And speaking of which, this thing is fully portable. It's about 30 to 35 pounds. You could probably fit it in the passenger seat of your car, or if you have a trunk, absolutely you could fit it in the trunk. And the dimensions are about it's about 17 inches this way and about 15 this way. So gives you a pretty good amount of space for boards. This board design that I came up with on KiCad is actually quite large for a circuit board, or for a hobbyist board, I suppose. So you could kind of see here that you could fit probably 3 smaller boards right next to each other, and then you have this whole length side to go kind of this way with everything. And then we have our power supply unit tucked away in the back, held together with these brackets here. It's not going nowhere. So you have a in-house power supply, all your boards are secured, and then whenever we get our Nano connected, it'll have its own CPU, which is pretty neat. All right, I think that just about covers everything. Our Z-axis is using a linear rail system there. And yeah, I think that covers just about everything. I think everything else has been covered in previous videos. If you have any questions, definitely hit me up and I will see to them. Now, we're gonna start with a dry test. So for this test, I'm just going to show that the machine can do every placement on this board. I do not have any 1206 resistors, so this side of the board here will be omitted. We're not gonna use that, but we will do this side. We only have the 4 components, so I'll do R1, R2, R3, and R4 whenever we do our live test. But for now, I'm just gonna show that the machine is calibrated and that it can perform all these placements here. So let's get into it. I'm gonna start by outlining the board. I'm gonna follow our fiducials here. So right now we're on our first one. I'll head back there. Nice. All right, we're gonna start with our resistor placements. Start with R1. There we go. Sorry about the glare on that video. Hopefully it didn't disrupt anything too much. All right, let's get into this live test here. I'm gonna set you guys down here so that way we can see the components getting picked up here. Here we go. Let's check out our results. Let's see how we did. It's not too bad. R2 has been giving me a little bit of difficulty, but I think potentially that could work in an actual build. Of course, we're not quite done yet, and I can definitely perfect that more. But the rest of my placements so far are really quite accurate, and I just couldn't be more happy with where we're at so far in this project. I really had a blast doing it, and yeah, and there's still more to come for sure. Let's see. I don't know why I switched my phone like that. Yeah, there's still more to come, so let's talk about that for a second. We still need to implement our camera vision. So like I said, our Nano, just a Nano over here, we've been playing around with it and messing with some models, some different vision models, and we've got it just about worked out. We're really quite close. The camera that we bought just isn't compatible, unfortunately. I think our Nano is a bit older, so we bought the Raspberry Pi high quality camera, which came out last year, 2024, and it's just so new, and I think it runs on just a different version of Linux, unfortunately. So we were just unable to get those to work together. So we are going to we need to find a different camera. Right now we're just using a webcam to test our vision and our recognition of different objects, things of that nature. So that will be implemented here soon, and we will have camera vision to detect components and placements and things of that nature. Next, I would like to implement our automatic feeder. Now here is a design that we got off of Bamboo. So it just uses a simple servo and then a gear back here, which isn't attached just yet, but the servo spins our gear and feeds the component tape through there. Now, ideally we'll have this set up just about here, pretty much in line with where the strip is now. But whenever we get that implemented, we will have just so much more efficiency, and we'll definitely be able to get our whole board built, no problem. And we won't have to worry about making sure the strip is straight or anything of that nature. So really looking forward to what comes next in this project. Like I said, it's been a blast and I've really enjoyed it. I'm happy to see it come all this way, really. Seems like I was designing the schematic just a couple days ago. But yeah, I'll see what other videos I can make with it along the way. I know I've definitely skipped a couple of steps in my process, and I definitely apologize for that. Just been very busy with senior year and all that. But yeah, alrighty. Thank you guys for watching. Like always, just let me know if you have any questions or want any information on maybe how to do this yourself. I would love to provide some of the documentation that we have for it. Even for OpenPNP, I can send you my configuration files or whatever you would like. So thank you guys for watching.